this does that, so just call that. And then call sort like this. Here's the array. Here's the size of the array, the elements of the array, and the string comparison. Right? So I call it like this, it sorts strings. I call it like this, it sorts integers. Okay? Code parameterized by the values, the array and the size, and the function, the comparison. So why do you have to cast the PA to avoid star star? C will automatically cast from anything star to avoid star, but not star stars. And the reason why is that void star is actually a type. It's kind of weird. But it's, you know, if you had an array of, if you have an int star and you want it to be a void star, you can cast it to a void star. You just don't have to. Okay, I want to look at one other example what we're done here. This is from assignment 5, where you're reference counting an object, this element thing, that had a value in it that was dynamically allocated. And there was this challenge that if you make that thing reference counted, that value thing needs to be free when the last reference count goes away and RC free ref frees the object. You know, so it looks like this. You have an element, and the element has a value, and these are both dynamically allocated. And the way that you solve this, who solved this problem? What? Is it too long ago? Okay, the way you solve this is to reference count both of them. So when you RC malloc the thing we wanted to reference count, this thing, you also had to RC malloc this thing, which you didn't really want to have to do that, but you had to, because the code that uses reference counting will never call free. Free will be called automatically with some call to free ref. So every time you keep ref on E, you also keep ref on the value. Free ref on E, you also free ref on the value. But there's another way to do this that's better. And that's we can define malloc so that it has an additional parameter that I'm going to call a finalizer. This is very much like a C++ constructor. So this will be a function that we want to have RC free ref call when it's about to free the object. It'll be saved with the reference count like this, and as I said, when free ref is about to free the object, reference count goes to 0. If there is a finalizer, it's optional, it could be null. It'll call that function. So now what you can do is so here's the malloc R. So I'll RC malloc the element, but just regular malloc the value. But when I RC malloc the element, I'll say, well, when you go free that element, you got to run this finalizer method. So final element finalizer name without the parentheses is a pointer to this code. And it will get a pointer to the element, and what it will do is free the element. Okay? So this is an example of a callback. And we're going to look later on in class another use of callbacks when we get to synchrony. If you're in tree 10, who's in tree 10? You've done callbacks, but you've done probably with promises rather than actually straight callback. But it's very common programming technique. It's like, okay, I'm going to call this function, I'm going to give it another function that I wrote, call it at a certain point. Okay, so pick this up next time. Have a great weekend.